Welcome to the second lecture of fourth week of the course Unit Operations of Particulate Matter, and in this week we have started discussion on flotation process in lecture 1, and that we are continuing in lecture 2 also. Now, as far as flotation is concerned, in this particular lecture we will discuss different steps involved in the flotation process. Then we will discuss different equipment used in the industry for flotation purpose, and through one example we will discuss how the recovery is done, or how the calculation for recovery of a compound is carried out in a flotation process. So, let us start the lecture 2 with steps of flotation. Now, as far as the steps of flotation are concerned, the very first step is the grinding to liberate the mineral particle. So, if you remember the last lecture, we have discussed that we take the rock directly from the mines, and these rocks first crushed or grind into a small particle, and then these particle which consist different types of ore that will be used for flotation process. So, first step of this is to grind or to crush the rock into small particles to liberate the mineral. Secondly, reagent conditioning to achieve hydrophobic surface charges on the desired particle. So, once I am having this mixture of a small particle, we enter into the conditioner where different reagent like collector, frothers and modifiers, all these are added, so that whatever component we want to be floated off, that its surface characteristic can be changed. Then formation of a stable froth on the surface of the flotation cell. Here in the flotation cell, after conditioning, material enters, and then water and air enters into this, it forms a slurry, and after flotation process we have a stable froth on the surface of the flotation cell. And finally, separation of mineral laden froth from the bath. So, that we have to separate the froth, and then after this, breaking this froth, we can collect the mineral, we can collect the ore involved in this froth. We can recover the mineral or ore associated with this froth. So, here in this diagram, if you see, we have shown the flotation circuit. Here reagents and ore are added into the conditioner where different flotation agents are added to prepare the desired surface of the material, and then it enters into the rougher. Rougher is nothing but the flotation cell where flotation will be carried out, flotation of desired material will be carried out, and that will be collected as a concentrate. The tailing of this, that is material which sinks, that enters into the scavenger, and then finally we have the tail as well as concentrate. So, this is the circuit of flotation process. Now, in this slide, here we will discuss selective flotation from silica, and why we are use the selective flotation, because it is the mixture of galena, sphalerite, pyrite and silica. So, we have to recover galena, sphalerite and pyrite from silica one by one. So, let us start the flotation process for this. As we have discussed that the first step is to grind the rock. So, here feed enters into ball mill, and after crushing this feed, after crushing this feed, the product or the outlet stream of ball mill enter into the classifier, where smaller particle which can be classified, which can be separated from the larger particle. So, larger particle, then a certain size will be recycled back to the ball mill, and the product of classifier or the outlet stream of classifier, or we can say the fine particle which we have collected through classifier, enters into the conditioner. So, you see here we have the conditioner where xanthate, sodium cyanide and zinc sulphate enter. Now, what is the purpose of xanthate is it will work as a collector. It means it prepares the surface hydrophobic. Now before that, sodium cyanide and zinc sulfate has to modify the surface of component. For example, sodium cyanide is used to depress pyrite that we have discussed, and zinc sulfate is used to depress sphalerite. So when we are adding these two modifiers, sphalerite and pyrite will be depressed and galena would be at floating condition. So after this conditioner, the material enter into the rougher, where pine oil will be added, and pine oil will be used as a frother to give a stable froth. So as we know that we have already depressed pyrite and sphalerite, so only galena will be floated off. So the concentrate of rougher, which consists of maximum amount of galena, it will enter into the cleaner. This Cl is nothing but the cleaner, because along with the galena some particles of sphalerite and pyrite may come into this. So again here we have the flotation process where galena should be floated off, and we have collected this concentrate of cleaner as pure galena. Here recovery is very promising. So tailing of cleaner will be recycled back to the rougher because it contains some amount of sphalerite as well as pyrite. In the similar line, the tail of rougher, which consists maximum amount of sphalerite and pyrite, and it may contain some amount of galena, so it will enter into the scavenger where galena will be floated off, and in terms of concentrate of scavenger, galena enters into or recycled back to the rougher. The tailing of scavenger, it consists of pyrite, silica and sphalerite. So you see, in first step only galena will be floated off, or only galena will be separated. So after this it will again enter into the conditioner. Now here this stream consists of sphalerite, pyrite and silica, and here we are adding xanthate, lime, copper sulfate. Now why we are using copper sulfate? Because copper sulfate is used to activate the sphalerite, and then the mixture enters into the rougher where we are adding pine oil and lime. Pine oil as a frother. Lime is used to maintain the pH of the media, because if you remember the critical pH of sphalerite, that is 10.4, and we are maintaining higher pH of the media, so only sphalerite will be floated off. Concentrate of this rougher consists of maximum amount of sphalerite. It will enter into the cleaner because it consists some amount of silica as well as pyrite. The concentrate of this cleaner consists of sphalerite in pure form, and tail of cleaner, which consists of pyrite as well as silica, it will recycle back to the rougher, and similarly rougher tail enters into the scavenger to collect the tail, and where whatever amount of sphalerite is available, that is recycled back to the rougher as a concentrate. Tail of scavenger consists of pyrite and silica. It will further enter into the conditioner, and in this conditioner xanthate and copper sulfate in excess will be used. So if we use copper sulfate in excess, it will activate pyrite, and then following same procedure of rougher, cleaner and scavenger, we can get pyrite as a concentrate of cleaner and silica as a tail of scavenger. So this is the selective flotation process to recover galena, sphalerite and pyrite from silica. Here I am having one example that how the calculation and flotation process will be carried out. To illustrate that, a mixture of copper sulphide and silica is to be separated by froth flotation technique, where feed is 1.5 × 10⁶ kg per day, and the following data is available. Data is available over here. You see, here we have feed, that is the initial feed which is entering into the rougher. So here we have rougher, tailing and concentrate, final tailing, scavenger and cleaner. So you see here all three units are involved. So when we are considering the feed, it consists of 98% silica and 2% copper sulfate, and similarly composition of other streams are known. Now if you see, when we want to recover the copper sulfate, the final concentrate, which is the concentrate of cleaner, it consists of 99% copper sulfate and 1% silica. And similarly final tailing, which is the tail of scavenger, it consists of 99.6% silica and 0.4% copper sulfate. So you can see here the recovery is very promising in flotation process. What we have to do in this problem is to determine the flow rate of each stream and percent yield. So let us start the solution. Here this diagram speaks about the process. Feed, which we are denoting with A, enters into the scavenger, and then concentrate of scavenger. Here feed, which we are denoting with A, enters into the rougher, and concentrate of rougher enters into the cleaner, from where we are getting final concentrate, and tail of rougher enters into the scavenger, from where we are getting final tailing as a pure, almost pure product. So different streams are there, which we have named as A, B, C till G. So overall material balance on the system is when A is equal to E plus G. As we have to recover copper sulfate from silica, we make the balance of copper sulfate for entire system. So whatever is available over here, that is A into XA equal to E into XE plus G into XG, where X is used for denoting the mass fraction of copper sulfate in individual stream, where A is the total feed, which is 1.5 times power 6 kg per day, XA is 0.02, XE 0.99 and XG is 0.004. How we can obtain this? For that we have to refer the previous table. XA is 0.02. So you see XA is nothing but copper sulfate in feed, so that is 2%. So 0.02 we can take from this, and similarly we can take other fractions. After solving these two values while putting the value of flow rate as well as mass fraction, we can get E and G as the value shown over here. In the similar line, we can make the balance over scavenger, where F stream is equal to G plus C, copper sulfate balance in the similar line, where G is this much, because G we have already calculated from overall balance. So that G we put over here, and XF, XE and XG, these value we can obtain from the table which is shown with the problem. After solving these two, we can calculate flow rate of stream C as well as stream F, and which we can obtain like this. And similarly, when we are making the balance over we are making the balance around cleaner, so stream should be D, so overall balance should be D is equal to B plus E, and similarly component balance E we know already, XD, XE and XB we can see from the table which is given with the problem, and here we can get the value of D and B as these values. Now next we have to calculate is the percentage yield of copper sulfate. So that is nothing but EXE divided by AXA. So you see E we have calculated like this. Total recovery is 99%, total feed is 1.5 times power 6, and XE is given at and XE is given as 0.02. So we can see that 80.33% yield we can obtain from this flotation process for this particular example. Now here we will discuss different equipment which are used in the industry for flotation purpose, and mainly these are of two types. First is mechanical cell and second is pneumatic cell. So let us discuss the mechanical cell. Now what happens in mechanical cell, suspension enters into this, and this mechanical cell use the impeller, and through the periphery of this impeller air enters, So you see, when slurry enters into this slurry contains the water and air we are entering through the agitator, and when this is agitated vigorously, the air which is entering into this, that is broken into small bubbles, and these bubbles float in the cell. So here we have the water as well as air, and suspension carries different compound, different agents which make the surface hydrophobic or hydrophilic. So you see here, when we are considering this particular section, its enlarged view shows that some particles are having a bubble over its surface. So you see here, the bubble formation is not very uniform, but in some cases more bubbles are involved and in some cases less bubbles are involved. So when bubbles are significant, so that the complete material can be floated off, it will be collected at the. So if bubble formation is significant and ensures that the material should be floated off, so that would be collected as a concentrate, or that would be collected at top of the mechanical cell, and that will be collected as froth, which consists of material which is hydrophobic. And similarly from bottom we can take the tail. Now if you see this cell here, due to this impeller we call it a mechanical cell. So since the violent agitation is provided in such cells, more thorough flotation is obtained, but some gangue also could escape into the froth. So you see, along with the desired material, some undesired material can also enter into the froth because of this agitation. So here the quality of the floated material will be therefore poorer, though the yield will be almost 100%. So that we have already seen that yield in this case is promising. We can recover around 99, 98 or more than 99% material through this process, but because of mechanical or because of thorough agitation, some undesired material and some undesirable material are entered into the froth, and therefore it gives less pure component, less pure material in comparison to pneumatic cell. So here we have another flotation cell, which is nothing but the mechanical cell only. So here concentrate is collected from the top and tailing is collected from the bottom, that we have discussed already. Now if you want to study more about this, you can go through this link. Now as far as pneumatic cell is concerned, here we are using the compressed air, because here mechanical agitation is not done. So agitation is done through compressed air. When compressed air enters into the pneumatic cell, it provide agitation inside the slurry, and through this the air bubbles are broken into small sizes. So pneumatic cells use compressed air for agitation. They provide relatively mild agitation and produce a clean froth essentially free from gangue. If you see this figure, here we have the air which enters from the bottom, and it is the compressed air, so it provide agitation inside the cell. So you see here, its diameter is very less in comparison to mechanical cell. So whatever air enters, that is spread throughout the length easily. So they require around 50% more contact time than the mechanical cell, and the feet should be fully conditioned with flotation agents before charging to the cell. So here we have, after conditioning, feed enters into this, and contact time over here is more, because here agitation is done slowly in comparison to mechanical cell. And another advantage of mechanical cell is there, because agitation is carried out over there. We inlet the slurry which contains water as well as material which we have to separate, and then we can add flotation agents in the mechanical cell itself. So that is the added advantage of mechanical cell. Because of agitation, flotation agents as well as the flotation process can be carried out simultaneously in mechanical cell. However, in pneumatic cell that is not possible, and therefore we have to use fully conditioned feed where flotation agents are already included. So here we have discussed the working of pneumatic as well as mechanical cell. Now in this slide you see here one photographic image is shown, where how the bubble look like in actual system that you can observe. If you want to study about this more, you can go through this link, but as far as froth is concerned, in actual sense it looks like this. And here also you see at the top froth is there. So here flotation unit is very large, so that will be always a mechanical, because pneumatic cell very large we do not use. And here we have the flotation process of gold. If we have to recover the gold, froth of flotation process looks like this. So you can study more about this in this link. So here we have discussed different equipment which are used in industry. Now there is one added information which I would like to share, that in single mechanical cell we have different compartments, and these compartments are very large in number, like these are some more than 20 or like that. These compartments are prepared in a single container. So when we are considering very large flotation cell, the main unit is one cylinder only, and where we are making different compartments by placing metal sheet, and therefore the flotation will be carried out in each compartment simultaneously, and their froth will be collected at the top, and their froth will be collected at the top, and that froth we can take out that froth from one point only. So you see inside this we have different compartments. So as far as froth is concerned, that will be collected at one point only. Here we have the summary of this lecture, and this summary consists of summary of lecture 1 and lecture 2 of this week. Here flotation process is defined along with its industrial applications, operation of flotation, its mechanism, flotation agents and steps involved in flotation process are discussed. And finally we have discussed industrial flotation equipment, which are mainly mechanical cell as well as pneumatic cell. And here some of the references are given in terms of book. However, some web links are also given in respective slide, which you can use for further study. And that's all for now. Thank you.